Hi, welcome to my video on the extra volume problems. Before we start, you should know the formulas. Let's review the formulas for the volume of different geometric figures that you should have memorized. Let's match up the name with the formula. A rectangular prism is a rectangle like this, and it's a rectangular box which has a length, a width, and a height. So the formula for that, volume is length times width times height, and that's number 3, length times width times height. A square box is the same, but the bottom of the box is a square. So the bottom is length and width is the same, and a height. So S squared h, and that's x squared h, is number 8. 8 is the volume of a square box, square base box square. A cube is the same design again. The only thing about a cube is that all edges are the same. So the length is S, the width is S, and the height is S. So there's S times S times S, which is S cubed. And S cubed is number 5. The volume is S cubed. A rectangular prism is, a triangular prism. Triangle is a triangle that's moving through a distance. And there's the diagram. So the triangle on the end. So remember, volume is base area times height, or distance, whatever you want, length or height. You could call it that the length. So the base area of the triangle is half the base times the height times the length, and that would be number 6. So there's the triangle going through a length, so it's number 6. A square pyramid is a square is on the bottom, and from a height, there's the peak of the pyramid. So again, volume is base area times height. So the base of a square pyramid is a square, which is S squared, times the height. So S squared H would be, oh, we forgot. That's in relation to the rectangular prism. Rectangular prism or box, but the pyramid is 1/3 of that. Pyramid is coming from a prism, so therefore it's 1/3, so that would be number 2. So be careful. It's the same as S squared H, but is 1/3. A right cylinder is a right cylinder means that it's at right angles to the surface. There's a right angle right there, and so it's a base area times height. The base area of a circle is pi r squared times the height. And pi r squared h is number 1 for the area of a right cylinder. A sphere is 4/3 pi r cubed. Something you have to memorize. It's number 4. You have to memorize a sphere because you didn't develop it as base area times height, so it's 4/3 pi r cubed. And a cone is 1/3 of a cylinder. So a cylinder is base area times height, but a cone is 1/3 of that. So it's 1/3 pi r squared h. Cone on a cylinder, cone is 1/3. Pyramid and a prism, 1/3. So that's number 7, 1/3 pi r. So there's a circle going through a distance and is 1/3. So that's number 7. That's a review of formulas that you should have memorized. And you sit down and repeat and repeat and repeat until you get every one of them right, hopefully 100% of the time. So I have a word practice here. You should take each problem I have now and look at the problem, pause the video, and work each problem out, and then press play to see if your answer is correct. If it is, great. If it's not, go back and look where you made a mistake. Number 1, a rectangular pool is 9 meters long, 5 meters wide, and 2 meters deep. If it's 2/3 full, find the cost to fill the pool at $25 a cubic meter. Okay, what do we have? We have, notice we have cubic meters. Cubic meters means you have a volume. So cubic meters, you're talking about a volume. So the volume of a rectangular pool, and a rectangular pool is this shape. Okay, and it's long, so you can say it has 9. The width is 5, and the depth or height is 2. So the volume of a pool is base area times height. The base is a rectangle on the bottom there. And so there's length times width times height. So the length is 9, the width is 5, and the height is 2. So when you multiply all that, 45 times 2 is 90. So that's 90 cubic meters, meters cubed. And it says that the pool is 2/3 full. So we have 2 ways to do this. I can go 2/3 full, 2/3 times 90. So that 3 into 90 goes 30. So I get 60. So 60 full. And if it's 90 is the full amount, the total volume of the pool, and it's 60 full, that means there's 30 cubic meters left to fill. That's one way. Another way is that if it's 2/3 full, then 1 is the whole amount minus the 2/3. That's 3/3 as a common denominator of 3. 3/3, common denominator is 3, so it's 3/3. That's 1/3, so it's 1/3 to fill. So 1/3 times the total volume, and as over 1, 3 into 90 goes 3, so you also get 30 cubic meters. Just 2 different ways to think about it. Your choice which way you want to do it, either of these. Anyway, we have 30 cubic meters, and we're paying $25 per cubic meter. So the cost is 30 cubic meters times 25, so that's $750 would be the cost to fill the pool. Number 2, what we have here is looks like a box, a rectangular box with 4 tennis balls inside. The 4 tennis balls, each with a 2.5 centimeter radius, are placed in the rectangular box. Each ball fits tightly in the box, touching the sides. How much empty space is there in the box to the nearest cubic centimeter? So notice the ball is just fitting in. All sides of the ball is touching this side, this end, the top, the bottom, and this end here. So that means we have to look at, we have a radius of a ball is 2.5 centimeters. That means if the radius of the ball is 2.5, the diameter is twice the radius. So that means it's 2 times 2.5. So that means your diameter is 5 centimeters. Again, the units are centimeters. Now that means that if you look at this, if you look at the box, which is like this, and the ball is going around like that, that means that the ball will touch this way, which is 5, and it'll touch up and down, which is 5, and it'll touch this way, it's 5. So the box has, if you think about it, a 5, could be 5 wide right here, that's 5, it's 5 high right here, and if the ball is touching here, that's a 5, that's a 5, and a 5, and a 5 over to the end of the box, so it's 5, 5, 5, 5. So the box is 5 by 5 by 20. So the volume of the box is length times width times height. So it could be, say, 20 the length, the width is 5, and the height is 5. So that gives us 25 times 20, so that's 500, and again is cubic centimeters, the volume of the box. Now, the balls are in the box, so the balls is taking up the space, so we have to get the volume of the balls. So the volume of the sphere, which is a ball, is 4 over 3 pi r cubed. So that's 4 over 3. Pi is 3.14. The radius of the ball is 2.5, which I indicated here, and that's cubed. When you plug that in your calculator, 4 divided by 3 times 3.14 times 25 cubed. You use your brackets like I have here in the calculator, and it ends up to be 65.4166, etc. And you could round that off now, or you could, if you want to round that off close to what you want, is 65.42. But there's 4 balls, so there's 4 balls, so it's 4 times 65.42. And that leads to 261.68. And we have the volume of, should I say the space, is the volume of the box minus the volume of the balls. Let's put BOX here. So the box is 500. The balls is 261.68. When you subtract, you get 238.32. And we said we're going to round it to the nearest cubic centimeter. So the nearest is right here. So that becomes a 0 and a 0. This number to the right is less than 5. So it's a 238 as the final answer. So the number of cubic centimeters, cm3. So just a review, problems help you think. Always remember the formulas and keep thinking. Number 3, again, pause the video and read the problem and work it out, and then press play and come back and see if you got the right answer. Let's read this one. We have an ice cream cone. An ice cream cone. AB is 60 millimeters long. If the ice cream cone costs $0.08 or 8 cents a cubic centimeter, find the cost to fill the cone to the nearest cent. Notice we're dealing with a volume. Volume is cubic centimeters, so that's a volume. And so we got to get the volume of so what we have is the volume of a cone, and we have the volume of a hemisphere, not a sphere. A sphere is all the way around like a ball. So this is a hemisphere, H-E-M-I-S-P-H-E-R-E, a hemisphere. So to get the volume of a cone is base area times height, but it's 1/3 of a cylinder. So that's 1/3 pi r squared h. A sphere is half hemisphere, so it's a half 4 over 3 pi r cubed. So that cancels out. 2 and 4 goes 2, so it's 2/3 pi r cubed. So that's the formula for the volume of 2 of these when you add them together. You're looking at them. 1/3 pi r squared h, 2/3 pi r, and that's a cube there, my little mistake. That's a 3, because it's volume. Now, how are we going? We have AB. We have AB to be 60 millimeters. But we notice that the volume is in cubic centimeters. So we have to say that AB is 60 divided by 10. So we get 6 centimeters, because we have to have the same units. Again, the volume is in cubic centimeters, so the millimeters got to convert. So if we draw AB as 6 centimeters, that's the diameter as 6 centimeters. That means the radius is half of that, so the radius is 3 centimeters. Okay, now we can get the hemisphere if we want. The hemisphere could be figured out right away because we don't need radius, but to get the area of the cone, or sorry, the volume of the cone, I need my radius and height. So I can get the hemisphere right now. Okay, let's go and get the hemisphere. The volume of the I'm just going to call it HEMI. And the volume is 2/3 pi r cubed. So that's 2/3 times 3.14 times 3 cubed. And when you use your calculator and go 2 divided by 3 times 3.14 times 27, and you'll get 56.52. And that's, again, it's in centimeters, so that's cubic centimeters. Now we need the volume of the cone. But to get the volume of the cone, we realize that we have the radius of the cone, which is 3, but we need the height. So look at the diagram. The height is from here down through from the top, perpendicular to the diameter. So that's a 3, and that's a 3. We have 5 is here and 5 is here because we have a slant height. The height of the cone is here. This is the slant height. So the two of these are equal, so that's a 5. Now if I go over here and reproduce that diagram to make it plainer, I have B is there. I have a 3 here, perpendicular. I have a slant height of 5. So using my Pythagorean, C squared is A squared plus B squared, I'm going to call this my height. That's the height right there. So the height is from perpendicular from here to the diameter. And the C is the side opposite the right angle. So C is 5. A is H. And B is 3. 5 squared is 25. H squared, 3 squared is 9. H squared is 25 minus 9. Move it over. H squared is 25 minus 9. Move the 9 to the left side and change the sign. So H squared is 16. So H is the square root of 16. So H is equal to 4. So now I have my height and my radius. So now I can get the volume of a cone, which is 1/3 pi r squared. H is the circle moving through a height. So that's 1/3, 3.14. Radius that we have on the cone is 6. Radius is, diameter is 6. The radius is 3. Better be careful. So it's 3 squared, and the height is 4. When you multiply all that out with a calculator, you'll get 37.68. And again, that's cubic centimeters because it's volume. So we have it all done. Now the total volume of all of it put together, T, is the sphere, hemisphere, the volume of the hemisphere plus the volume of the cone. The volume of the hemisphere is 56.52 right there. The volume of the cone is right here, 37.68. When you add that up, it adds up to 94.2. And 94.2, now that's the number of cubic centimeters of ice cream we're going to get. But the cost is 0.08 cents or dollars times 94.2. I'm going to C for cost, and that works out to be 7.536 when you use a calculator. And that's it in dollars now, because this is dollars. And we multiply, and we have to round it off to the nearest cent. So the nearest cent is $7.53. So the nearest cent is here. So this becomes a 0. 6 is greater than 5, so that 3 add on 1 is 4. So it's 7.54. So the cost is $7.54. Good little problem. Excellent on volume. Good working Pythagorean there. So you see that these problems are meant to make you think. And if you can think these out and know what you're doing, you'll be doing okay. Now another extra problem I threw in here is we have a concrete pipe that has hollow in the middle and is all constructed of concrete. The thickness of the concrete pipe is, so this thickness here is 0.5. 0.5 is the thickness of this concrete through here. And it's in feet. The radius of the inner one is 1.5, so that's 1.5 on the inner one. So that means if the inner circle got 1.5 and the thickness is 0.5, so the radius R of the outer, I'm going to say the outer piece of tubing or cylinder is 1.5, add on 0.5 or 0.5, so that's 2. So it's 2 feet. Now we get the volume of the outer one, and we get the volume of the inner one, and we subtract, and we'll add the volume of the concrete. So the volume of the outer cylinder is, we got a base area times height, so that's pi r squared h, so that's 3.14. Remember, when you have a cylinder, you got a base area moving through the height. So that's a circle moving through a height. The radius is 2, so it's 2 squared. And the length of the pipe is 12 feet. So that's 12 feet from there to there, so that's the length. And so we put 12 in here, and when we work that out, we get, with a calculator, 150.72. is the volume, and the volume of the inner pipe, the inner cylinder, again is base area times height, and it's a circle, pi r squared, and times the height, and that's 3.14, and the radius of the inner one is 1.5 squared, and the length is 12, and when you multiply all that out with a calculator, you get 84.78. And if you subtract the volume of the concrete that it takes to construct the pipe is the volume of the outer minus the volume of the inner, and so that's 150.72, subtract 84.78, and again this is volume, so this is in feet, so notice this is cubic feet, this is cubic feet because you're dealing with volume, this is cubic feet, and when we subtract this we get 65.94, and that's cubic feet. So we says rounded to the nearest cubic foot, so the nearest cubic foot is right here, so this is 0 there, 0 there, this is a cubic foot, nearest unit. This number is 5 or greater, so we round this up, so 60, so the 5, add on 1 is 6, so there's the 6. So the total volume of the concrete is 66 cubic feet. So, good little thinking, working it out. Again, problems are designed to make you think. And we have more practice, means pause the video after you read the problem, work them out, and play it back to see if you get the right answers. Do one at a time. Now we have find the difference in their volumes, and the difference can be positive or negative, but let's get the positive difference. That means the largest one take away the smallest one. So this is a volume is base area times height of this triangular prism. The triangular prism is, we can call it height or length. Let's call it length, not to get confused. So right here we have that the length is 20 in terms of the triangle. Then the height of the triangle is 12 and the base of the triangle is 5. So we get a half base times height L. Notice I use an L here because I don't want to get confused with the height of the triangle. So there's a half. The height base is 5. The height of the triangle is 12. And the length of triangular prism is 20. And a half of, if you want, cancel the 2 and get a 10. That's 60. 5 times 12 is 60 times 10. So that gives us 600. And is in centimeters, so it's cubic centimeters. Now we have the volume of a pyramid. A pyramid is 1/3 base area times height, and it's 1/3. The base of a pyramid is a square. It says 12, 12, and 12. So that's S squared H. So that's 1/3. The side of the square is 12. So there's the area, 12 squared. And the height is AT is 18. So that's 8. That's 12 goes there. So this height right here is 18. Let's put an 18 there. Height is 18. 1/3 into 18 goes 6. So we get, if you want, we get 144 times 6, which ends up to be 864 cubic centimeters. And the difference is the volume difference, DIFF for difference, is 864, subtract 600, and you get 264 cubic centimeters in the difference. Right. Okay, let's continue. Read this one over. We got number 6. Again, pause the video, read the problem out, work it out, and then come back and press play to see if you got it right. A glass ornament in the shape of a right cylinder has a radius of 8 and a height of 15. So we got a right cylinder that's like this. And it says it has a radius of 8. So that's 8 right there. And it has a height of 15. One thing I noticed is centimeters and centimeters. So everything is okay. And the volume, say we want to fill up the box, so it's, notice it's a cubic box, and it says how many, it says, okay, let's continue. A cubic box with an inner edge of 20 centimeters, so we got a cubic box. So this is a box which is cubic, like this. And the cubic box has the inner edge of 20, so that's a 20, 20, and a 20. So what we're doing is putting that cylinder in here to protect it and putting styrofoam around it. And we want to find this, if you put the cylinder, this glass ornament, which is in shape of cylinder, in the box, then there's the space left is going to be filled up with styrofoam. So we have to get both volumes and subtract them. And the cylinder must be smaller than the box. It has to be to fit it in. So the volume of a cylinder is base area times height. So it's pi r squared h. So it's 3.14. R is, the radius is 8, so 8 squared times the height is 15. So that works out to be 3014.4. And the units are in centimeters, so it's cubic centimeter. The volume of a cube, all edges are the same, so it's S cubed. Length times width times height is the same. So it's a 20 cubed. So 20 cubed, 20 times 20 times 20 is 8,000. So the styrofoam, the volume of the styrofoam is just call it STY, is the volume of the cube minus the volume of the ornament. Or so that's 8,000 minus 3,014.4, and that works out to be 4985.6. And you want to round it to the nearest unit, so that becomes 0. This is more than 5, so we add 1 onto the 5, so it's 4986. And it's the volume of the styrofoam to protect the glass ornament in the box is 4,986. Okay, and we have one more problem to do, and it reads, the unit is inches for this measurement, so that's 16 inches and 20 inches. Find the volume of the cylinder to the nearest inch cubed or cubic inch, whatever way you want to say it. But to get the volume of a cylinder, the volume of a cylinder is base area times height. The bottom of the cylinder is a circle, so it's pi r squared h. Notice, memorizing the formulas, knowing how to derive is extremely important. You can't forget it if you think about, if you understand what you're doing. So, I have, let's see what we have here. I have a height of 16, which is this one. I don't have any diameter or radius, so I don't have any diameter or radius, so that's a question mark. And I have to go and get in order to get, I have a height of 16, but I don't have a radius, so I can't get the volume. But I remember that I have a triangle here, and if I draw that diameter across here, this is a right angle here. So what happens? I have a Pythagorean. C squared is a squared plus b squared. If I have two sides of a right triangle, I can get the third one using Pythagorean. C is opposite the right angle, so you always fill your C in first or your hypotenuse. That's your 20. We can call this my diameter now, because that's the diameter across there. And I can call B 16. So 20 squared is 400, D squared, and 16 squared is 256. And transpose, move it over to the left side and subtract. So D squared becomes 144. So D is the square root of that number, 144. So D squared is 140. D squared is 144. D is the square root of 144. D is equal to 12. And again, the units are in inches, so we just note that. So now we can do the volume. The volume is pi r squared h. So 3.14. If the diameter is 12, the diameter is 12 from there to there, the radius is half of that, so that's 6 and 6. So my radius is 6. So I had to take half the diameter to get the radius. So 6 squared times the height of 16. When you multiply all that with a calculator, you get 1808.64. And you got to round that to the nearest inch cubed. So that's 0, 0. 6 is greater than 5. So you add 1 to 8 to get a 9. So it's 1809. And it's cubic inches. Cubic inches of the volume. Again, I'm always stressed Pythagoras. And I hope you liked my video. If you did, click the like button. If you're not a subscriber, click the subscribe button and the notification bell, because there are many videos coming your way. Write a comment on my video if you wish. And visit my math website, mathfullyexplained.com, to get information on me, my degrees and teaching experience. Also get information on the strategy you're going to use to help you learn your math. And the content section tells you about the topics you're going to have online. Black font is the topics already there. Red font is the topics that will develop in the near future. Thank you very much. Bye-bye.